Welcome to my channel Cherish Physics. Subscribe my channel and keep watching. Let us see the quantum operators for several physical quantities. Quantum operators plays a vital role in wave mechanics. Let us see the first quantity. In classical expression, we can write it as R. In quantum operator, also we are going to use the same letter R to denote the position quantity. Next, let us see the momentum quantity. Momentum is implied by the letter P, and we know the formula P is equal to mv. The quantum operator for momentum is minus I h by 2 pi dou by dou x. Here we have taken the x component of the linear momentum of a particle. This is the quantum mechanical operator for momentum, and in the vector form we can write minus I h by 2 pi del. The symbol del implies dou by dou x. In a simple form, we can write the quantum operator for momentum as minus I h cross del, since h cross is equal to h by 2 pi. This is a very simple form. We can easily recall it very soon. Minus I h cross del. The next operator, angular momentum. Angular momentum is implied by the letter L, and we know L equal to R cross P. So the quantum operator for angular momentum is minus I h by 2 pi R cross del, or minus I h cross R cross del. The next quantity, kinetic energy. We know the formula kinetic energy equal to half mv squared. We are going to write this term in terms of momentum P. So we have to multiply and divide this equation by m. We get 1 by 2m into mv the whole squared. So we know mv is P momentum. So P squared by 2m. Kinetic energy equal to P squared by 2m. We have find the quantum operator for angular momentum, kinetic energy, everything in terms of the momentum P. Use this in this equation. So we get 1 by 2m into minus I h by 2 pi del, this is P, the whole squared, which is equal to I square. Minus means minus into minus plus, and I squared, its value is minus 1, so minus 1 by 2m h squared by 4 pi squared into del squared. So the quantum operator for the kinetic energy is minus h squared by 8 pi squared m into del squared. In simple, we can write it as, so with the help of this equation, keep 1 by 2m square. This term means minus into minus plus, and I squared, it is minus h cross squared del squared. So the value is minus h cross squared by 2m into del squared. We have written the quantum operator in terms of h and also in terms of h cross. The next one is total energy. Total energy, which is equal to kinetic energy plus potential energy. So the quantum operator for the total energy is minus h cross squared by 2m del squared plus ep, or we are going to write the quantum operator for the energy in terms of time derivatives. So its quantum operator is I h by 2 pi into dou by dou t. In this case, we have written in terms of the partial derivatives of x component. Here we have write the quantum operator for energy in terms of partial derivatives with respect to time. In a simple form, we can write it as I h cross dou by dou t. Likewise, we can write the quantum operator for any quantity. Let us see the quantity velocity. Velocity formula already we know. In terms of p, we are going to write, so P is equal to mv, therefore V equal to P by m, 1 by m into minus I h by 2 pi into del. This is the quantum operator for momentum. In a simple form, minus I h cross by m into del. So if you have to keep in mind one momentum quantum operator in your mind, means we can easily write the quantum operator for all the quantities like angular momentum, kinetic energy, total energy. And for velocity also we can write it. And another one formula we have to keep it in your mind is the energy formula in terms of time derivatives. Total energy equation for all the three component x, y and z. In classical representation, it is 1 by 2m px squared plus py squared plus pz squared plus v of x, y, z. This is the potential energy. Quantum mechanical operator, total energy can be written as minus h by 2 pi the whole squared by 2m into dou squared by dou x squared plus dou squared by dou y squared plus dou squared by dou z squared plus v of x, y, z.